Greatest common factor, or GCF. Greatest common factor is our go-to move when we are factoring polynomials. So if you notice, this first technique, and the one that we always want to use first, is GCF. We want to see if there's anything that we can pull out of this polynomial before we factor it further. So let's try this. So I'm looking at this one right here, and I see that 15 and 10 are multiples of 5, so I'm going to pull a 5 out. Then I'm going to look at my x terms. So I have x cubed and x to the first. So I'm able to pull 1x out of both of these terms. And then I have y squared and y to the first, so I'm able to pull 1y out of each of these terms. Now I have to ask myself, what do I multiply this 5xy by to get back to my original values? So 5 times 3 will give me 15. And then I need 2 more x's to get to x cubed, and 1 more y to get to y squared. Again, remembering that when we multiply, we add our exponents. So I've got x to the first, x squared, so 1 plus 2 is 3, and then y to the first, y to the first, so 1 plus 1 is 2. Now I need to get to negative 10, so 5 times negative 2 will give me negative 10. I have one x term. I need one x term, so that's all. And then I have one y term, and I need one y term, so that's all. So now I'm going to go ahead. This is my answer. Now I'm going to go ahead and check my work, because we should never lose points on these, because we can always check our work. And we check our work by working the problem backwards. And so if we distribute in, we should get what we originally had and we were told to factor. So 5 times 3 is 15. X to the first times x squared is x to the third. Y to the first times y to the first is y squared, minus 2 times 5 is 10, and then I have xy, which is my original problem, so I know I've done it right. Let's do this next one. So I have 4, 8, and 4. I'm looking for common terms that I can factor out. I can take a 4 out of each of these terms. Then I have x to the 5th, x to the 4th, and x to the 3rd. So I can take x to the 3rd out of each of these terms, and now I need to look at what I have left. So 4 times 1, I'm going to go ahead and write that even though I don't have to. 4 times 1 will give me 4. And then x cubed times x squared will give me x to the 5th. Minus 2 to give me that negative 8. And then now I only need one more x term. And then last but not least, minus 1. So that I end up with minus 4x cubed. And now again, I can work this backwards, so I'm going to distribute and just make sure I got that answer correct. So 4x cubed times x squared is going to be 4x to the 5th, and then 4 times negative 2 is minus 8, x to the 4th, and then last but not least, minus 4x cubed. Now for a little bit more difficult problem. I'm going to look at this problem up here at the top, and again, looking for my greatest common factor. So 6, 15, 21, 27. All of these are divisible by 3. So I'm going to pull a 3 out, and then I've got x to the 5th, 4th, 3rd, 2nd. So all of them can have an x squared taken out. Now I need to go through and see what I have to do to get back to my original number. So to get a 6, I'm going to have to multiply by 2, and I'm going to need x cubed, because 3 times 2 will give me 6, x squared times x cubed will give me x to the 5th. Now I need to get negative 15, so 3 times negative 5 will give me negative 15, and I need 2 more x's. Now I need negative 21. So 3 times negative 7 will give me negative 21. Up here I have x cubed, here I have x squared, so I'm going to need one more x. And then last but not least, 3 times 9 will give me 27. And I already have all of the x terms that I need. So I'm done with that one. And again, I could work my problem backwards to check my answer, and I should do that on quizzes and tests just to make sure I don't lose any points. Now this last one down here, again, I'm looking for common terms that I can pull out. So I've got 5. All of my numbers 10, 15, and 5 are divisible by 5. And then I've got a cubed, a squared, and a, so I can pull one a term out of each of these. B squared, b, and b cubed, I can pull one b term out of each of these. 5 times 2 will give me 10. I already have one a, so I need 2 more. And I have one b, so I need 1 more. 5 times 3 is 15. I have one a, I need 1 more. I have one b, I only need one b, so I'm done with that term. Then I have 5, and I need a -5, so that's going to be -1. I have one a term, which is all I have up here, and I have one b term. I need 3. So I'm going to go ahead and put b squared there. I'm just going to rewrite it since we don't normally write that one coefficient. And again, remember, we can work backwards to make sure that we got the answer that we started with, and I highly recommend you do that.